I would like to briefly cover the procedure for qualitative test of alkenes and alkynes. We start with the solubility and density of the product or the compound. First, we take a 10 milliliter test tube and add 2 milliliters of water and then the compound. And then look for solubility and density. As far as density is concerned, we're looking for a separation of the aqueous solution and the compound. If the compound is in the bottom of the tube, that means that compound has greater density in water. Of course, if it's floating, it means it has a density less than water. Then we want to proceed on and take 3 reagents and test these compounds for alkenes and alkynes. The 3 reagents are bromine, potassium permanganate, and sulfuric acid. We'll start with the bromine. We'll first take the hydrocarbon and place it in the test tube with 1 milliliter of methyl chloride and 2% solution of bromide and shake it well. The solution should turn a reddish brown color. Then once the reaction occurs and we get a positive result, we should have a clear color solution indicating there is an alkyne or alkene present in that solution. The second test would involve potassium permanganate. Again, we take another test tube, place the hydrocarbon in the test tube, then 1 milliliter of acetone and 1% solution of potassium permanganate. Then mix it well. We should get a purple color. When the reaction is good, it should turn a brown or dirty brown color, indicating that there is an alkene or alkyne present in that solution. The third test involves sulfuric acid. We want to take another test tube and place that acid in the tube first with 1 milliliter of that acid and the hydro compound, and mix it thoroughly. We should get a soluble mixture with an alcohol product, which again would prove that there is an alkene or alkyne present in that solution. There is another test that's used with alkynes, but especially with terminal alkynes, more specifically with terminal alkynes. And it's where you take 2 moles of an alkyne and mix it with a heavy metal like mercury. In this case, we use potassium mercury iodide in a sodium hydroxide solution. This produces 2 molecules of acetylide and a mercury as a product. This particular product will turn a white grayish color as a precipitate. This again would prove that there is an alkyne or alkane present. Now remember, with the first 2 tests, the bromide and potassium permanganate, they are not mutually exclusive. These 2 steps must be performed in each case in testing for alkenes and alkynes.